we bring this up, you can see how it breaks into sort of like plates here. So that's from fairly high tillage. So that's kind of what we're seeing. So what we're going to do now is we're going to take a few of these pieces of soil, and what we're looking for to see if it's very well aggregated, and it's not really coming up. Well, there's a little bit, but it's not coming apart really loose, and it's quite dense and so on. So that's telling me that it's not doing great things. So I'm just going to do a soil temperature now. So the air temperature right now is 22 degrees. And you can see right here, the soil temperature is roughly 27, 28 degrees. So a full 6 to 7 degrees above the ambient air temperature. And so the moisture that's at the surface here, even on a day like today where it's not terribly warm, will be evaporating. And then this moisture from further down is going to be moving up. And so the moisture that's stored in this soil is slowly evaporating off the surface. So we're going to take a sample of this soil here. I just labeled the bag N for neighbor, and we're going to do another test on it here in a few minutes when we do a similar sample at David's. And we can see some of David's past sins too. We see the tillage line here, but it isn't nearly as platy as what that neighbor's was. When we start to look, we're way down at the bottom here, and we're still seeing aggregation. So the plants are gluing the soil together to make aggregates. All the way down, it is quite nicely aggregated, so that is very nice. Whereas we didn't see that in the neighbor's field. It was more like this, blocky and hard. So once again here, we're going to take a few samples. I'm going to do one more test when we get up to David's shop and see if these plant glues and so on make any difference. So here we are in David's shop now, and we have the two soil samples in front of us, and in just a moment I'm going to drop them into the tubes of water there you see sitting, and we're going to time for a couple of minutes and just watch what happens. But before I do that, I just want to show what we're really testing here. So I just drew a picture of a soil aggregate, and you see the individual particles of soil here. And so what aggregation means is that they get glued together by the slimes and snots and poop and things like that of all of those millions of microbes that live in the soil. And the only way they live and work is if the plants are feeding them. And so what that does when the microbes start to glue them together, it pushes the particles apart. So we have space in here for air, for water, for roots to channel through, all those kind of things. When we don't have that space, it becomes very, very difficult for roots to enter, for water to be held in storage and so on. So these are absolutely critical for success. The more aggregates that we have, the better our soil becomes and the more resilient it becomes. And so what this test is going to do now, we're going to drop these aggregates into water, and the water will rush into these pores, and if the glues that hold them together aren't very strong, we'll see them disintegrate very quickly. And if the glues are strong, we should see very little soil settle out. I'm going to drop the N in first here. This is the neighbor's soil, so here I'm going to put in a couple of pieces of soil, and we'll just see what happens. And we'll put in David's soil. A couple of pieces here. That's a pretty big piece, but we'll put it in anyway. And we'll just see what happens here for a couple of minutes. So here we are now. We're just over a minute and almost 2 minutes on the clock now. And you can see that there's some notable differences there in the soil. The one on the left side from David and Crystal's farm here, you can see is still, there's the odd piece floating down. There's a little bit down at the bottom, but it's still, the water is pretty clear. We look at the other side where we didn't have any green plants working, and you can see that this soil is the water is pretty cloudy. And you can see down here, look at all of the soil that has broken apart with the water rushing in and smashing what few aggregates there was. It's quite a dramatic difference. You can see the difference in the color there. So the point is that it pays to keep it green as long as possible, keep those plants feeding the microbes. That's what we've missed in modern agriculture, is that little principle. The plants feed the microbes feed the plants, and in the process they create these aggregates here, which is what is absolutely critical for resiliency and success.